Right now, even if your engine feels perfectly fine, a single dirty sensor could be quietly stealing power, burning extra fuel, and shortening engine life, without triggering a single warning light. That's what makes this failure so dangerous. A component no bigger than your fingertip can make a healthy engine feel weak, fail emissions, and drain your wallet at the pump. Across repair shops in the United States, the same pattern repeats. Parts get replaced, money gets wasted, and the real problem stays hidden. Today, we're exposing the sensors that fail silently, and the one almost nobody ever cleans. If you appreciate information that actually saves you money and gives you power over your vehicle, then show your support right now by hitting the like button and subscribing to the channel. It's a small click for you, but a huge signal for us to keep providing you with content that truly matters. Let's start with number 13, the MAF sensor. The mass airflow sensor is one of the most critical and most neglected sensors in modern engines. Its job is to measure exactly how much air enters the engine so the ECU can deliver the correct fuel. Most MAF sensors use an ultra-thin heated wire. As air passes over it, the wire cools, and the ECU calculates airflow based on how much current is needed to keep it hot. The problem starts when dust or oil vapor coats that wire. Airflow data becomes inaccurate. Power drops, fuel economy suffers, and idle turns unstable, often with no warning light at all. Number 12, the MAP sensor. The Manifold absolute pressure sensor calculates engine load using intake manifold pressure instead of direct airflow. When vacuum is high at idle, pressure readings are low. When you accelerate, pressure rises, signaling heavier load. The ECU uses this data to determine fuel delivery. The sensor itself rarely fails. The real issue is contamination or vacuum leaks feeding it false pressure information. Cracked hoses, carbon buildup in the sensor port, or oil residue skew readings. The engine then runs overly rich, fuel economy collapses, and black exhaust smoke appears, often misdiagnosed as injector or fuel pump failure. Number 11, the oxygen sensor. The oxygen sensor is the engine computer's real-time feedback system for combustion efficiency. Mounted in the exhaust, it measures how much oxygen remains after combustion and helps the ECU fine-tune the air-fuel mixture thousands of times per minute. Over time, fuel additives, oil burning, and contaminants coat the sensing element. The sensor still works, but slowly. That delay causes the ECU to overcorrect, swinging between rich and lean conditions. The result is reduced power, higher fuel consumption, and failed emissions tests, even though no hard fault code may appear. Number 10, the throttle position sensor. The throttle position sensor tells the ECU exactly how much throttle the driver is commanding at every moment. Inside, a precision-resistive track converts throttle angle into a changing voltage signal. The problem begins as that track wears or becomes contaminated. Tiny dead spots form at commonly used pedal positions. When the throttle passes through them, voltage briefly drops or spikes. From the driver's seat, this feels like hesitation, jerky acceleration, or sudden power loss during cruising. Because the sensor still responds most of the time, these failures are often misdiagnosed as transmission or ignition problems. Number 9, the Crankshaft Position sensor. The Crankshaft Position sensor is the engine's timing reference. It tells the ECU exactly where each piston is and how fast the engine is rotating. Without it, fuel injection and spark timing fall apart. This sensor sits close to rotating metal components and easily collects oil residue and metallic debris. As contamination builds, its signal becomes distorted. The engine may crank longer before starting, randomly stall when hot, or briefly lose power while driving. Because symptoms appear intermittent, many shops suspect fuel pumps or ignition systems until the sensor is cleaned and everything returns to normal. Number 8, the Camshaft Position sensor. The camshaft position sensor works alongside the crank sensor to identify exactly which cylinder is firing. This allows precise sequential fuel injection and proper valve timing control. When oil contamination, sludge, or heat damage weakens the sensor's signal, the ECU loses that fine timing reference. The engine switches to a backup strategy with less precision. Idle becomes unstable. Cold starts take longer, and hesitation appears at mid-range RPM. These symptoms are often blamed on coils or injectors, but a contaminated camshaft sensor can quietly degrade performance across the entire driving range. Number 7. The intake air temperature sensor. The intake air temperature sensor measures how hot or cold the air entering the engine really is. That data matters because air density directly affects how much fuel the engine needs. Over time, oil mist and dust coat the sensor's sensing element. Once contaminated, it reports inaccurate temperatures. The ECU then delivers slightly too much or too little fuel at all times. The engine still runs, but power feels muted and fuel consumption slowly increases. Because the change is gradual and subtle, drivers rarely suspect a sensor this small is responsible. Number 6. The engine coolant temperature sensor. The coolant temperature sensor tells the ECU how warm the engine truly is. That single input controls cold start fueling, idle speed, ignition timing, and cooling fan operation. When internal corrosion or sludge forms around the sensor, its readings drift. The ECU may think the engine is cold when it's fully warm, or hot when it's actually cold. Fuel economy drops, idle becomes rough, and long-term engine wear increases. Because these symptoms mimic multiple system failures, a faulty coolant temperature sensor often goes overlooked during diagnostics. Number 5. The vehicle speed sensor. The vehicle speed sensor tells the ECU how fast the car is actually moving. That information controls shift timing, fuel cut during deceleration, cruise control, and traction logic. Mounted on the transmission or differential, the sensor is exposed to oil, road grime, and metal debris. When contamination builds on its magnetic tip, signal pulses become erratic. The transmission starts shifting unpredictably, the speedometer may jump, and cruise control disengages randomly. Many drivers fear transmission failure when the real issue is a dirty speed sensor sending false movement data. Number 4. The knock sensor. The knock sensor is bolted directly to the engine block and acts like a high-precision microphone. Its job is to detect abnormal combustion before it damages the engine. When knock is sensed, the ECU instantly pulls ignition timing to protect internal components. Over time, dirt, corrosion, or improper mounting torque reduces the sensor's sensitivity. Real detonation may go unnoticed, or worse, false signals force the ECU to constantly retard timing. The engine feels weak, heavy, and unresponsive. Many vehicles regain lost power instantly once the knock sensor and its mounting surface are cleaned. Number 3. The oil pressure sensor. The oil pressure sensor is the last line of defense before engine damage occurs. It monitors pressure inside critical oil passages and triggers warnings when levels fall too low. Over time, sludge and varnish from degraded oil clog the sensor's inlet. This creates delayed or false readings. The engine may be starving for lubrication while the dashboard shows normal pressure, or the warning light may flicker without cause. Because drivers trust the gauge, this sensor failure can allow severe internal damage to develop silently before any real alert appears. Number 2. The fuel level sensor. The fuel level sensor lives submerged inside the fuel tank and is almost never inspected or cleaned. It uses a float connected to a variable resistor to report fuel quantity. Over time, varnish from low-quality fuel, oxidation, and debris wear the resistive contacts. The signal becomes inaccurate. Fuel gauges stick, respond slowly, or lie completely. Drivers think they're getting poor fuel economy or running out of gas unexpectedly when the real problem is bad data. Because the engine still runs normally, this sensor's failure is often dismissed as a minor inconvenience. Number 1. Sensor connectors and wiring harnesses. The sensor that fails more than any other isn't a sensor at all. It's the connectors and wiring harness that carry their signals. Every sensor depends on clean power, solid ground, and an uninterrupted signal path to the ECU. Over time, heat, vibration, moisture, and corrosion degrade terminals and wires from the inside out. Signals drop out, spike, or disappear completely. Sensors get blamed and replaced, but the problem remains. In real diagnostics, simply cleaning connectors, repairing grounds, and securing harnesses often restores perfect engine behavior in minutes.